topologies, work through the relation list, and build a topology for the subject and object if there is no relations has been constructed. If the subject and object in one sentence are the same, then remove this relation. Here is the example we get for the case study 1. You can see that the topology we get from the relation associative model is nearly the same as the original topology. So we can guess here the relation or associative model is the most efficient one among the 3 models. In the experiment, I also report this part. I also report that because I think the relation associative model is the most important one. So I do many experiments to prove this one. Now I have already introduced the 3 models with its topology construction method. Now I go through the processing framework. In this project, I implement one software to analyze the plaintext and then get topology. The whole processing framework is in this figure. You can see that there are 3 major parts. One is plaintext processing, the other one is the process, and the third one is topology construct. The input is the plaintext and the output is topology. In the first procedure, I do the plaintext processing. Firstly, I remove the function, then I remove the unnecessary word. So what is the unnecessary word? In this project, I mean the word, verb, and noun are the important word. Because verb and noun are also be served as the subject and the object, so I cite verb, but noun are the important one. I also get the word database, and the database is from the word.NET for all the verb and noun. After that, I will use the pattern match to get the tuple, as I described before, the subject, the predict, and the object. Based on the model I input, I will choose. You want to use the co-class model, the semantic feature model, or the relation associative model. Based on these 3 models, I will use related topology method to build the whole topology. After that, the topology will be output. Now I'm making a demo for it. Here, as I has already submitted the code on the GitHub, you can easily use git clone plus my link, then download this software and use it. Here, this is the source code of this software, and the upper level directory includes the database. In the database, there are 2 files. One is the noun dictionary, and the other one is the verb dictionary. In the upper level, there's a readme file, and this is the text file. Now go through the source directory. You can simply make it. After that, you will get the command here, the semantic analysis. The uses of this method is here. There are 2 parameters, one is mode and the other one is the input file. For example, let's give one demo here. You choose the mode and 0 and the input file. 0 means the colon carries model, 1 means the semantic feature match model, and 2 means the relation associative model. And the input file is here, and this is the input file. Hey, sorry, this is yeah, correct. You can see that here. The plan after you input the plaintext, this is the output. In each output, you can get here the vertex and vertex 1, vertex B, and this is the ID 1, ID 2, and this is the weight. The output is in here. From here, you can see that the first column is one vertex, the second is another vertex, and the third one is the weight we get. You can also use the other 2 model, for example here. And here. So the output is in the word not adjacent matrix file. This software is easy to use, and for the further analysis, such as the MATLAB code I will use another MATLAB program to analysis. This software is easy to use, and you can simply download it and modify it. This is the demo, and then I will go on the presentation. Now I do the experiment, show the experiment results and the analysis. Here, for the experiment results, I use two evaluation metrics. One is the major concept list similarity, and the other is topology established similarity. The first one is used for the concept detection. The second one is used for the relation detection. So how to use the first one? The basic idea here is the sorting the concept according to its weight and match this list with predefined one. Then you can calculate the similarity based on the similarity value divided by the total concept number. For example, the concept after you sort is A, B, C, and the predefined one is A, C, B. Here you can see that there are only one similarity and the similarity value is 0.33. So this is the way you calculate the major concept. For the topology established similarity, the calculation method is match the established relation with the predefined one, we call the match number. If then you match each of the predefined relation list with the established one and record the unmatched number. Use the first one to divide the other two. You will get the similarity value. Let's take one example. If the established you get is A to B, A to C, and the predefined one is A to B, A to C, and B to C, then the total similarity value you get is, because you have one unmatched, then the similarity value is 2 divided by 3 equals 0.667. Here I should mention that the relation has direction, so if you use the concurrent model and you can only get the undirected graph, so in this evaluation method you will use half of the similarity value instead of 1. This is the one point you have to focus. Now I have show the two case studies. For the two case studies, here the two case is the simple one, very simple. One is the case study here about the mammal animal. The other case is about the computer, and I developed by myself. For the detailed things, you can see the project report. Here it talks about the major concept list similarity. From this, you can see that the relation associated model nearly get one similarity. It means that it detects the correct topology with the correct concepts. The co-occurrence model performs better than the semantic feature match model, as it has got more relations among different concepts. The other one is topology established similarity. You can see also here the relation associated model is nearly, the value is nearly 1. It means that the relation associated model is the most efficient one. And the semantic feature match model, for the case study 1, you can see that the relation is 0. You remember that I showed the topology constructed by the semantic feature model of case study 1. It has no relations, so the relation here is 0. For the case study 2, it has much higher similarity value than the co-occurrence model. Based on these two case studies, I can see that the relation associated model is the most effective one, and the co-occurrence model is better to detect the concepts, and the semantic feature match model is better to detect the relations. Here I also talk about the specificity and the sensitivity of the co-occurrence model and create